Hello class, we're going to talk about lesson 4-6 today, arithmetic sequences. Our objectives are we can recognize and extend an arithmetic sequence, and we can find a given term for an arithmetic sequence. Here's our vocabulary alert for the day. We've got sequence, which is just a list of numbers that often forms a pattern. We also have the word term, which is just each of the numbers that are in a sequence. We've got an arithmetic sequence, which is a sequence where the terms differ by the same non-zero number, which we call D, and the common difference, which is that non-zero number that each term in an arithmetic sequence differs by, which we also call, or we know that as D. Let's look at our first example, identifying arithmetic sequences. We need to determine whether the sequence appears to be an arithmetic sequence, and if it is, we need to find the common difference in the next three terms in the sequence. So we've got the sequence 12, 8, 4, 0. Our first step is to find the difference between the successive terms. So by finding the difference between each successive term, we need to ask ourselves, to get from 12 to 8, what do we need to do? Well, we can subtract 4. To get from 8 to 4, we can also subtract 4. And from 4 to 0, we've also got to subtract 4. So because we are adding negative 4 or subtracting by a positive 4 from one term to the next, we can say that the common difference, or D, is equal to negative 4. So now we can move on to step 2, which is using the common difference to find the next three terms. So to do that, what we're going to do is take the last term we were given, 0, and we're going to just keep subtracting 4 from it. So 0 minus 4 is negative 4, and then we've got to do that another time. Negative 4, take away 4 is negative 8. And if we need to find the next three terms, we need to do that one more time. We take away another negative 4. Negative 8 take away 4 is negative 12. So the next three terms are negative 4, negative 8, and negative 12. So we found out that it is arithmetic because it is subtracted by 4 from one term to the next, and that the next three terms are negative 4, negative 8, and negative 12. Let's take a look at another example. So we've got the sequence 1, 4, 9, 16, and that keeps going forever and ever. So step 1 is to find the difference between the successive terms. Alright, so from 1 to 4, we can add 3. From 3 to 9, from 4 to 9, we can add 5, and from 9 to 16, we can add 7. So even though this forms a pattern, we are not adding or subtracting by the same amount from one term to the next. So that means this sequence is not arithmetic. So with sequences, we often use the variable a to represent terms within that sequence, where the variable a sub 9, where we have an a and then a little letter 9 below it, represents the 9th term in a sequence. So to designate any term or the nth term in a sequence, we're going to use the notation a sub n. So these are all these sub numbers, these index numbers, represent the position of a term. So if we have a sub 1, that means that this is the first term. If we have a sub 2, that is the second term. A sub 3 is our third term, and the pattern keeps going. There is a formula for finding the nth term of an arithmetic sequence. So the nth term of an arithmetic sequence with the common difference d and the first term a sub 1 is written as a sub n is equal to, or the nth term is equal to the first term plus n minus 1 times our common difference. We're going to use this formula for our next couple examples. So we are going to find the 22nd term of the sequence that starts with 5, and then 2, and then -1, -4, and that keeps going forever and ever. So our first step is to find the common difference. So we need to find out from 5 to 2, 2 to -1, and -1 to -4, is there a common difference? So from 5 to 2, we can subtract 3. From 2 to -1, we can also subtract 3. And from -1 to -4, we can also subtract 3. So our common difference, or D, is -3. Now we're going to use that formula to write a rule for the 22nd term. So we're going to use the formula a sub n is equal to a sub 1, or the first term, plus n minus 1 times d. So we've already found what the common difference is. We should also know what the first term is, and that's just the first number in the sequence. So for this problem, that's 5. So we need to write a rule for the 22nd term, or a sub 22. That's just going to be our first term 5 plus, in parentheses, 22 minus 1 times -3, our common difference. So now we can simplify this. We're going to first go 22 minus 1 to get 21. So we've got 5 plus 21 times -3. And then we can do some multiplication. -3 times 21, which will give us 5 plus -63. Now we can do some addition. 5 plus -63, or just 5 minus 63, is another way to write that. 5 minus 63. That's going to give us -58. So that means the 22nd term, or a sub 22, is equal to -58. We've finished finding the nth term for finding the 22nd term of a sequence that starts with 5, and then is followed by 2, -1, and -4, and keeps going forever and ever. Let's try another one. So we're going to find the 15th term of a sequence where the first term is 7 and the common difference is 3. We actually weren't given the sequence, we were just given the first term and our common difference. So again, we're going to use the formula a sub n is equal to the first term plus n minus 1 times the common difference. So we're looking for a sub 15, which is going to be equal to 7, our first term, plus, in parentheses, 15 minus 1 times 3, our common difference. 15 minus 1 is 14, so we've got 7 plus 14 times 3, and 14 times 3 is 42, so we've got 7 plus 42 through multiplication. Now we can add. 7 plus 42 is 49, which means the 15th term, or a sub 15, is equal to 49. Alright, let's move on and do our last example. So it's a travel application. The odometer on a car reads 60,473. Every day, the car is driven 54 miles. What is the odometer reading 20 days later? So our first step is to determine whether the situation appears to be arithmetic. And since the sequence for the situation is arithmetic, because the odometer reading will always increase 54 miles every day. So step 2 is to find the common difference, the first term, and n. So since the odometer reading will increase 54 miles every day, that means D is 54. And since the odometer reading starts off at 60,473 miles, that means A1, or A sub 1, is 60,473. And since we want to find the odometer reading 20 days later, we're actually going to need to find the 21st term, because the first term is day 1. 20 days after day 1 is 21. So n is 21. So step 3 is to find the odometer reading for A sub n. So let's do that. So again, we're going to use the formula A sub n equals the first term plus n minus 1 times the common difference. So we are looking for A sub 21 is equal to 60,473 plus 21 minus 1 times 54. Using the order of operations, we're going to start by going 21 minus 1, which is 20. So we've got 60,473 plus 20 times 54. Now we can use some multiplication. 20 times 54, that's going to give us 60,473 plus 1,080. Now by using addition, we will find that on the 21st day, or 20 days later, the odometer will read 61,553 miles. So that wraps up lesson 4-6 on arithmetic sequences. For the rest of your homework, I would like you to do the your turn problems on your guided notes. See you later.